Now, regexes are complicated, so I'm going to start off by showing you some resources, places you can go to learn more information about regular expressions if you want to. And then I'm going to cover 3 ways that PowerShell actually uses these things, including the match operator, the replace operator, and the select string command, which is going to go through a bunch of files that I've got looking for particular pattern matches. Regular expressions are a very complicated language, very nearly a programming language completely in their own right. So my goal in this nugget here is not really to make you a master in the regex language, but to rather show you some resources that can help you master the language if you're interested, and show you more specifically how PowerShell uses regular expressions. So let's start with some resources. This is regexlib.com, and it's a really useful online repository for regular expressions. For example, we can browse by category. Let's look at something for addresses and phones. All right, so this is designed to validate Spanish phone numbers. I'm just going to scroll down until I find something kind of short that we can play with in the next one. Here, right, this is a good one, U.S. postal code. So I'm going to grab this whole regular expression, and I'll actually explain what some of this is, but I want to use it to show you another tool, which is regextester.com. This is a pretty neat online tester. And I actually use this a lot just to play with regular expressions because you can do it interactively. So I'm going to paste this in. And then what you do is you put some text down here that you want to test it on. So that's a U.S. postal code. And the idea is to see if your regular expression, which sits up here, matches anything down here. And sometimes what I'll do just to test it is I'll stick a little X in there to see if it's going to replace everything. Now, this is telling me that the regular expression did not actually pick up the postal code because it's not showing the postal code having been replaced with the X. And that happens a lot. And this is actually probably because it's a little overcomplicated. So let's just simplify it a little bit. Here's what we're going to do. I'm going to put in a character class. So \D stands for digits. And you'll notice what this has done now is down here in the result, it's actually found every single one of the digits and replaced them all with an X, because that's what I told it to. That's what's going on right down here. So \D is a character class. It stands for any digit character, so that's pretty easy to understand. What I can also do is tell this to look for a more specific pattern. I need exactly 5 characters. Now you see it's looked for any sequence of 5 characters, 8, 9, 1, 2, 3. You'll see that's highlighted in red, and then in the result it's replaced all 5 characters with a single X. So in curly brackets, that number is telling me how many digits I want. I could grab the other ones too. Let's tell it I want at least 4 characters, but no more than 5 characters. So now that it's able to recognize 4 characters, it's grabbed the 4, 5, 6, 7 and replaced that with an X. And it's willing to take up to 5 characters, so it's also grabbed the 8, 9, 1, 2, 3 and replaced it with an X. So that's what the curly brackets are. They specify a count, or how many times you want the preceding thing, in this case the digit character class, to be replaced. And that's one of the reasons I like this tool, is it's just a great way to fool around with regular expressions. Here's another one. This is a character class also. \W is a word character, which means it'll pick up anything that isn't white space. You'll notice in the result down here, it's replaced every word character with an X, but it's kept all the white space the same. I could say, let's see, we can also do a set, I guess this would be called, in square brackets. Give me anything from A to Z. And so now, although digits are considered word characters, I've taken those off the table by saying that I only want letters A to Z. Now, character classes like this, normally in a regular expression, would be case sensitive. So you'll see stuff like this too. People will put multiple classes in there that way, or multiple ranges. Windows PowerShell controls the case sensitivity with its operators, and you'll get to see that in a minute. So just understand, if you're repurposing or stealing someone else's regular expression, that Windows PowerShell does work a little bit differently in that regard, because it gives you the ability to be case sensitive or not, regardless of how the regular expression is written. So the last resource I want to show you is a book. And this is kind of the Bible of regular expressions. Mastering Regular Expressions, currently in its 3rd edition. This really dives into the regular expression language in an enormous detail and also has specifics for the .NET Framework's implementation of regular expressions, which is what Windows PowerShell uses. So if you really want to become more skilled in this language, then that's a good way to do it. So what I'm going to do now is dive into some of the ways PowerShell uses regular expressions. And I've got some regular expressions that I've pulled up, and I'll explain those regexes as we use them. You should be able to pick up a few basics of the regex language as we go through this. But again, my real focus is showing you how PowerShell actually utilizes these things. So let's close all this stuff and get to it. So we'll stay in Windows 7 and use PowerShell version 2, making sure I'm administrator, although it really shouldn't matter for this example. Let's take a string with some letters and some numbers. And we're going to use PowerShell's match operator. Now, the match operator is designed to do regular expression matching, meaning it's going to take a regular expression. There's \d. I'll add the plus. That means match the \d one or more times. So it's a repeating thing. Now, there's a couple different versions of this. Match is case insensitive. CMatch would be case sensitive, although for digits it wouldn't matter either way. You've also got not match, which simply reverses the logic. So if there is a match, this will return false, and if there isn't a match, it will return true. And there's also a C not match, which is the case-sensitive version. We'll just play with match. Now this always returns either a true or a false if there is a match or not. And it also populates this $matches array. And $matches 0, so the first element in that array, will always contain the complete match. So the D plus here matched 345, and that's because it was the first sequence of digits, and it stopped matching the minute it ran across something that wasn't a digit. You'll notice that .NET Framework and PowerShell, therefore, regular expressions are what they call non-greedy. So having found this match, and then having lost it when it hit this non-digit character, the shell stops looking for more matches. So it's not going to automatically go find this next sequence of digits. You can do something called capturing, and that involves using parentheses. And what you're telling it now is, I not only want you to match, but I want you to capture this portion of it. So let me show you the difference here. We'll put in a character set, have it also look for a repeating sequence of A through Z. Now there's a match there, but if we look at matches, you'll notice the complete match was A, B, C, D, 3, 4, 5, right? So here we go, A through Z, yep, that's good, still good, still good, still good. And then we ran out of A through Z, and so we started matching the next portion, which is the one or more digit characters, all the way through here, and then it stopped. And that's what we got here is the complete match in matches 0. But we also asked it with parentheses to capture the sequence of digits, and so that winds up in matches 1, the bit that it actually captured. You can have it capture more than one bit. For example, let's have it capture this A through Z sequence separately. And if we look at matches now, you'll see that the first thing it captured was A, B, C, D, and the second thing it captured from the second set of parentheses was 3, 4, 5. So this whole business with capturing is a great way to yank a particular portion out. Here's another good example. Let's try and put this to actual use. Let's come up with an email address, right? somebody.something@company.com. And let's see if we can match that. And what we want to do is we want to pull out just the person's first name. So we're looking for the somebody piece. So in our regular expression, that means we're going to be capturing something. And we're going to try and capture \W+, so word characters. Now, if you know for a fact that in your regular expression, let's say you're familiar with your email naming convention, you know that only A through Z is going to be valid, then instead of specifying word characters, which might include a number, you could just do the A to Z set with a plus. So I want to capture that, then I want a period, but the period actually is a special character to a regular expression. A period is a wildcard that stands in for any single character. So to get a literal period, I have to put a backslash in front of it. Backslashes kind of act as an escape character inside of a regular expression. And then we're going to have more A to Z, and then we're going to have an @ sign, which is going to be followed by more A to Z, which is going to be followed by another literal period. And then let's say we want to literally match COM. So that's a match. That means the entire email address matched the regular expression. And we might use that for input validation. We might say, provide me an email address for the new user. And I'm going to make sure it matches this particular pattern that represents our standard. And before I accept that and go ahead and create the user account or whatever. But in the matches collection, you'll also notice that we were successfully able to capture just the first name out of that. So it's kind of a neat set of tricks. You're not only matching the entire string or a hunk of the string, you're also grabbing just that little bit out in a way that you can access it directly. I could say matches 1 and just get that piece of information. So let's pull this back up and let's see what happens when we add some other strings to the end of it. So there's still a match. Let's see what was actually matched. We still matched just this portion of it. And that's because that's the only portion of the string that conforms to our pattern. This doesn't work because although it would start to match this A through Z part, right? Test does match that. Nothing in our pattern allows for a space. So PowerShell probably started looking at this and said, yeah. Oh, you lost me right there. Oh, but here's now this, yes, this matches the pattern right up until there because the pattern doesn't allow for any spaces. You can use a \s to represent space characters. So let's say I wanted to accommodate that test being there, A through Z, plus, followed by a space character. Still a match, but if we look at matches this time, by now allowing that A through Z plus a space character, it's pulled this test into the portion that it was able to match against the pattern. So that's the match operator. It's a pretty straightforward little dude. You can read more about these. Help about regular expressions. So help about _regular_ expressions. Also provides a brief little tutorial on the regular expression language and shows a little bit more about how to use that match operator. So it's another good place to explore if you're not ready to go buy a whole book on these things yet. Before we leave the match operator behind, I want to show you one more trick. Let me pull up that match we did with, oh, I've got so many things in my history, with that email address. There it is. Remember this guy? And when we did this, we were capturing the first name of it, right? We used the parentheses around that bit. Well, it's easy enough to refer to that, as I already showed you, using matches 1, but what if you wanted kind of a little bit friendlier of a way to do that? Well, you can do what's called a named capture. So inside the parentheses that define the portion I'm going to capture, I'll put a question mark, and then in quotes, I'll create a name for this capture. Now these quotes can be a little bit tricky. I've put the entire regular expression into double quotes, and that means it's okay for me to use single quotes in it. Let's do this first, and then I'm going to show you a couple variations of it. So now if we look at the matches collection, instead of that being in matches 1, it's in matches name. So I can get to that more easily. So it's called that now. So let's go back and what if I had done single quotes like this? I'm going to hit enter, and I expect an error message because it's seeing this as the regular expression because that's where the quote ends, and then it does not know what to do with any of the rest of it. So a way that you can deal with that is to double up on these dudes. Now I'll get that same thing. So keep in mind, from previous nugget, double quotation marks is going to look for variables in here, and it's going to replace them with their contents. And that's one reason to use double quotes. But if you don't want that behavior, it's a reason to stay away from double quotes and switch to singles, which don't have that variable replacement trick. But if you're going to do a named capture in your regular expression, then that's how you would put the quotes around it, because those need to be single quotes in there. So named captures, very, very useful trick also. Another Windows PowerShell operator that accepts regular expressions is the replace operator. Now, usually you'll see folks do something like this. This is technically a regular expression right here. It's just a regular expression that consists only of literal characters. And this is how most folks will start out using the replace operator. What it's going to do is take this string, find all occurrences of that pattern, and replace them with that. So we get that. That gets replaced with X. But you really can use this as a complete regular expression. For example, let's say I wanted to stick a dash in the middle, and I want to do that by finding an occurrence of the pattern that starts with a space, is followed by one or more letter characters, A through Z, and followed by another space. So I'm thinking that'll match from here all the way over to here and replace it with a dash, and that's what I got. So that replace operator, it's kind of a little secret that that thing actually supports regular expressions. I mean, it's documented in the about files, but who sits there and reads the manual, right? Nobody. But it's really, really useful because it can actually do multiples. So let's stick another one in here. And in this case, the replace operator is specifically designed to go find every occurrence of this pattern. So it matched this pattern and this pattern, replacing both of them with dashes in the output. So it's a really useful thing if you've got even a large string where you need to go in and pick out certain things and replace them with something else. The replace operator is a fantastic way to do that. Another great little string manipulation trick. Now the replace operator can also do some fun tricks with capturing regular expressions. So let's do this. I'm going to put a name in here. Let's say I've got a situation where I have a bunch of users' names and I need to change them from first name, last name to last name, first name. I'm going to use replace, and I'm going to use a regular expression. Now I want to start by capturing A to Z, keeping in mind that PowerShell is going to be case insensitive here. There's a C replace if you need it to be case sensitive. It's going to be case insensitive. So we'll take one or more of those, and that's my first capturing expression. Then I'm going to look for a space, and then I'm going to capture, again, case insensitively, another A to Z plus. And I want to replace that. Now, a couple of tricks here. Here, I'll show you what not to do. Those captures are going to be automatically placed into variables. The first capture will go in $1, and the second capture will go in $2. So by putting $2 first, I'm going to take the last name and put it first. The problem is double quotation marks do that variable replacement trick, and so that won't actually work. What you need to do is make sure that this last bit is in single quotes, or if you insist on double quotes, you can escape the dollar sign so it doesn't treat it as a variable. Because this is technically not a variable, it's a capture reference. So here's the result of that. So this first capture went into $1, which I told it I wanted last in the new string, and the second capture went into $2, which I told it I wanted first, and so I reversed those around, and then I scrolled down really fast. Okay, so let's see if we can make that a little prettier by putting a comma in. There we go. So that's a neat thing. You could feed a bunch of strings to this type of replace and quickly fix your output. Again, just really illustrates how useful regular expressions can be in a lot of different places within PowerShell. Now for my next trick, I want to show you something that regular expressions really get a lot of use from, and that's finding patterns or text matches in text files, such as log files. So I've got, here on my drive, I've got several directories of IIS log files. So let's do a get child item. We'll recurse through all of those and only include the files that have .log. So those are all these IIS log files I have. Now look, if you'd like to play with these same files, I'll show you where you can get them, because I actually have them online, so you can download them and mess around. Go to morelunches.com, click on Learn Windows PowerShell 3 in a month of lunches, go down to the Downloads section, and you'll see the IIS log files. And you can just pull those down as a zip file. They're not very large, just a few megs each, it looks like. So they'll pull down real quickly and be able to use as some play around stuff. So let's start with this. I'm going to grab all those files again and pipe them to select string. Now select string is designed to take regular expressions. So here's how you give it a pattern. Let's do a portion of an IP address. So let's tell it that we want to look for a space character. So that would be the beginning of the IP address. So there's a space before it. And then I want to look for a digit of 1 to 3 characters in length. And then I want to look for a literal period. And we'll leave it there. I mean, that's obviously not a complete IP address. That would just be the first octet of an IP address. But I want to show you what the output looks like. So by default, this thing looks on a per line basis. So what it's doing is scanning through every single file. you can see at the beginning of the line of output, there's the file name. And then it's going to show me that on line 221, here's the entire line of text where I found a match. And I'm guessing the match was probably, there's my space, 1, 2, 3 digits, and a period. So it shows you the entire line that matches. Here's another way you can do this. Now that I've got an IP address in here that I know what it is, we're going to enter that as a literal match. 10.211.55.30. So let's say that's an intruder's IP address or a particular user's IP, and I want to find all the log files where it appears. So I'm going to go through every single log file I have and ask select string to do that. Now it's still going to treat this as a regular expression, which means technically I should be escaping with a backslash these periods. Otherwise it's going to allow any character to be in that place, and it might potentially mess up my match. But what I'm actually going to do is add its simple match parameter, which says, hey, the pattern is no longer actually a regular expression. It's just straight text. Don't try and treat it like a regex anymore. And rather than showing me the actual lines that matched, just show me a list of files that contain that IP address. There I go. So I'm going to clear the screen so you can see that output all by itself. So it's literally just showing me a list of the files where it found that. It's grabbing the first match for me, so it found it there. And that's a much quicker operation then. It doesn't have to scan through every file. It just finds the first match for that string and says, yep, it's in there, and all he's looking for is a list of files where it appears. Doesn't matter how many times it appears. So select string is really useful for that too. Obviously this is a command, so you can just run help select string to learn a lot more about it. I could have added minus all matches, and that would have forced it to list all of the matches that it found. Quite a lot of little fun things you can do here. You can force it to be case sensitive. It's case insensitive by default. You can ask for context, which means when you find a matching line, show me a certain number of lines before and after that, so I can kind of see where the matching line fits in. Give me some context around it. So there's lots of other ways that you can manipulate this thing, but it's really, really useful way to use regular expression matching, particularly because it lets you pipe in things like file names and so forth, and it knows how to go open those things up and crank through them and find every single match that's in them if that's what you need. So that's a pretty good overview of how Windows PowerShell uses regular expressions. Now again, my goal wasn't to dive too deep into the regex language itself. I showed you some resources where you can go to pick up regexes that other people have written, to test regexes online, and that book, Mastering Regular Expressions, which is so popular people actually just refer to it as MRM, MRE, Mastering Regular Expressions. What's important is how you use those regular expressions inside PowerShell, and that's the match operator, the replace operator, and the select string command that I showed you. Those are all great ways to leverage regular expressions for a variety of different purposes in your scripts and functions and applications that you develop. I hope this has been informative for you, and I'd like to thank you for viewing.